It's nice to hear a talk about that introduces, well, it doesn't introduce functors, but it mentions functors and monads. Yeah, so BOSC is becoming more and more heading towards the informatics side on that one, and there's a reason for that. So I'm giving a BioRuby update talk today, and in the tradition of BOSC, we have, it started with a number of bio projects: BioPerl, BioPython, BioRuby. We got a lot more now: BioJS, BioHaskell, BioCamel has come up. I'm going to introduce a few more soon, I'm sure. So, but BioRuby is sort of, it's not a test of the screen. It's actually, we're kind of fading in the background. So, for several reasons, and this talk is about that. So, BioRuby and distributed development. The list of people here, the core maintainers, I should say, of what is now considered BioRuby. The ones that are in italic have been really productive this year. They've contributed most of the code. I also changed it. Would like to change the name of the BOSC, but anyway. So, what is it to manage a project? Yeah, what you really want to do is get everybody together and point it in the same direction. And in reality, this does not happen. In fact, we're lucky to have so many cats. And there are standoffs too, right? So, and this is within the BioRuby project, but we also have other projects. And to be honest, I think Python has won. Yeah, Python, I think it was a Slashdot 2 weeks ago. That is the largest programming language in education. Also in the bioinformatics community, a lot of the code that's being produced is actually Python code. But I'm not using a Commodore these days, so there's still a place for other languages. And one thing I want to touch on, we heard by Camel just now. Oh, Camel, sorry. So why, I've done a lot of languages. Why am I still programming in Ruby? And actually, most of my code is being written in Ruby. Because it's dynamically typed. It is really important, I think, in bioinformatics. One of the problems with Haskell and Camel is that they're statically typed languages, or strictly typed languages, I should say, which is really good for performance. But when it comes to rapid prototyping and putting things together and doing one-offs, yeah, you definitely want a dynamically typed language. And the families are there: Ruby, Lisp, Python, Perl, R, and JavaScript. And unsurprisingly, 5 of them are very popular in bioinformatics. Ruby is object-oriented programming, though I'm leaving that behind. But a lot of people like that. It's got pretty good functional programming support. I'll come back to that later. So does Lisp, so does Ruby, so does Python, so does Perl 6. So does JavaScript, and so does Coffee. And if you can see that in my list, the Coffee has got a little comma in front of it, which actually means that it's not lazily parsed. It actually turns into JavaScript. So JavaScript is mentioned twice there. Ruby has great meta programming. I think in many ways it showed the way. It actually got its inheritance from Lisp, which is the 50-year-old language that had it all. And it's becoming more popular these days. Python has good meta-programming support, and Perl 6 also. And unsurprisingly, in bioinformatics, they are there. But I think the main difference and trade-off for me every time is that Ruby code is readable. Yeah. I put the little stars there. Is this on purpose? These are called the earmuffs, I think, in Lisp jargon. But what it means is that when I read Ruby code, when I read my own code, yeah, I can actually read it because the language gives you a lot of clues. Yeah, and Perl does that too, but it's a bit over the top, right? It gives so many clues that you cannot read it anymore. But when I read Lisp code and also when I read Python code, it doesn't give me that many clues about what I'm reading. So, and I find that that's actually a very defining factor why I like Ruby. When you just saw the OCaml code in the previous talk, that's also a language that gives a lot of clues. The code that was shown on screen, I could quite easily read that. Yeah, so the other thing is that Ruby attracts the right crowd. The people who use Ruby, they don't choose a programming language by default. Right? They didn't choose Ruby because their boss told them that you need to do the programming in Ruby. Probably the boss told them to program in Perl, or in Java, or in Python. Even so, despite they have to learn they work through all these languages, they end up trying Ruby and they say, hey, I like this shit, right? And that's my type of crowd. So where are the Ruby people strong? They're leading initiatives in web frameworks, as you know. Rails is really defining. Testing frameworks, Travis continuous integration, which is being used by all communities here, I think. Web solutions, GitHub is written in Ruby. Hulu, Heroku, Twitter was written in Ruby initially. For software deployment, we've got Homebrew, Chef, Puppet, Vagrant, and they're all being used by Cloud Bio Linux, for example, which is written in Python. But if you look at all these projects, you can see that they're all meta, right? I mean, they're all dealing about innovation and innovation happening at the process level. So what does this have to do with BioRuby? That's my cat. We typically innovated the process, right? So we introduced tools to create packages. Actually, Ruby comes with a pretty good packaging system. And we said, okay, rather than have one centralized project, why not divide all the work over different packages and have people contribute within their packages rather than having one centralized project? And that's what we did a couple of years ago. Raoul here wrote most of BioGem, which basically is a command line tool that generates a new project. It creates a directory structure. It has templates for creating executables or foreign function interfaces. So if I want to create a new project, this is basically the command I give. I say with bin, with FFI, and it's there. And not only that, it will push the project to GitHub. It will push the project to Ruby gems and also to a centralized repository, which I'll show in a minute. And we wrote a paper below in 2012. And this is actually a very exciting month. This month, because we got our first citation for this paper. So and it wasn't a self-citation. So in the last 2 years, we've gained 100 projects this way, right? And in the last year, we've got 6 new contributors, and only 2 of them are from the Google Summer of Code. And I think for a project that is fading away, that is not bad. So also we wanted to make clear how people, that if people just generate projects on GitHub, you don't keep track of them. And I was really pleased to see the BioJavaScript people that they have their own repository of projects that they keep track of things. We have something similar called biogems.info, where you see the project name, you see who has written it, a description. If you click on the light bulb, it will take you to the GitHub source code. You've got the green and red as the Travis continuous integration. And this is for Ruby now, but we would like to do the same also for Perl and Python and Camel for all the projects that are interested in participating. And they don't have to, we could give them a special URL, it doesn't have to be biogems.info. But I would like to create one central repository where people can actually find functionality. And we should, what we're doing is we're getting beyond the language wars. Well, since it's a BioRuby update, I'm just going to quickly go through this. This is most of the work that's been done over the last year, so we've added a lot of RDF support. That's for the semantic web or linked data. This is work by Joachim Baran, who's joined Michel Dumontier's lab, who's sort of the guru in this stuff. We have a new tool called RDF2JSON, which translates RDF into JSON, so you can feed it into a NoSQL server, which is really nice. And the important thing is that all these tools, and also the tools I'm going to show next, that they have command line interfaces. So what we're actually doing now in the Ruby community, by default, we create command line interfaces. So most of the tools that are being used, you don't actually have to use Ruby. You don't see it anymore. Okay, more projects. Some of them I'll touch on tomorrow. Let's see. So, the BioRuby community from now on, or by project from now on, we probably call the project formerly known as BioRuby, or the community formerly known as BioRuby. We have no hang-ups about computer languages. We reach out, we cross over. Just to quickly touch on Ruby, and it's nice that the Camel talk was just before here. I actually studied OCaml 8 years ago, and that hasn't changed much, and I think it's a really nice, interesting language. What is missing in Ruby is functional programming support, concurrent programming support. It misses pattern matching, it should say here. It misses macros. Yeah, and these are all also missing in Python and Perl. So I'm proposing a new language of the year, which is called Elixir. And it's done. Okay, so I'm gonna, let me see. Yeah, this is a new programming language. It's a love child between Ruby and Erlang, if you're interested. It's actually a programming language that ticks a lot of boxes for me. So this is my final slide. So when we talk about the Ruby DNA, we've distributed development. We're not tracking it centrally anymore. We're reaching out. We want more tools. We're creating more libraries. We're learning more languages. GNU GUIX, or GNU Geeks as it's called, it's a package management system of the GNU project, and Cloud BioLinux play a very important role. And if you define the Ruby people, the Ruby DNA, I think we're sticky, we're reaching out, and we're crossing over. Thank you.